Okay, so you've got your data in Jamovi. You've installed Jamovi, you're ready to analyze data. The two types of analyses we're going to be working with are t-tests and correlations. They're pretty dang straightforward. Let's get started. A t-test is a simple analysis. It just tells you, is there a difference in the averages for a dependent variable between two groups, your independent variable. So a t-test can answer questions like, are boys taller than girls on average? Or do the times to run a mile improve from before to after taking a running class? Now, those are actually two slightly different questions for two slightly different t-tests. You've got independent t-tests and paired t-tests. An independent samples t-test is when you're dealing with data that has two separate groups, usually two separate groups of people, like are boys taller than girls. In this case, boys and girls were two separate groups of people, so you'd want to run an independent samples t-test. Your paired samples t-test is going to be for situations where you have two data points from the same person or any situation where data is related. So the question, did mile times improve from before to after taking a running class? So you're gathering data from the same person before and the same person after taking a running class to see if they got better at running their mile. The reason that you need to do the two different types of analyses is that the math is different between the two, and I really don't want to go into them in more detail. To be honest, in most cases, you will get um, you will get similar results regardless of which one you used, but there might be small differences. It's going to be pretty easy to tell which one you're supposed to use if you put your data in correctly. So let's take a look at what results your t-test gives you. To do your t-test, you go to Analyses, t-test, and choose your independent or paired samples t-test. For your t-tests, your independent samples t-test is going to involve one continuous dependent variable and one categorical independent variable. I'm sorry, this is obviously backwards. And then your paired samples t-test is going to run two continuous variables, but your categorical independent variable is actually in there. We'll see that how that works in a second. So let's go ahead and take a look at what your t-tests give you. You can think of your t-test as having a null and alternative hypothesis or a research hypothesis, just like we've seen in this class so far. The null hypothesis for the t-test is that the two means are the same. The research hypothesis is that the two means are different. When you put your data into the t-test, you're going to put your dependent variables where it goes and your grouping variable or your independent variable where it goes as well. You'll notice in the corner here, the type of variable is going to be limited because you can only put continuous variables for dependent and only categorical for independent. Here's the results that it gives you. A bunch of numbers that maybe don't mean anything to you, but they're not too complicated. The output that it gives you is a t-statistic. This is the statistic, the number for the t-test. Usually a higher number means there's more of a difference, but you don't need to memorize that. That comes from there. You get a df value. That's telling you something about your sample size for your study. Again, you don't really need to know exactly what it means. You just need to know where to get it, and your p-value. And we know what p-values mean, whether or not something is significant. In this case, 0.06. Is that significant? It is not, because it is greater than 0.05. So here's your quick and dirty description of what each one of those mean. In this class, we're not going to be working too much for between versus within differences, so don't worry about that. Again, your sample size, don't need to know that definition. So I'll take the star off of this slide for you so it's not confusing. And here is the data for the differences between a between and within subjects, or a paired samples and an independent samples t-test. The long and short of it is when you do a paired samples t-test, your result is going to be a little bit more significant than it was for the independent samples t-test. You see here, based off of the standard error is a little bit bigger in the independent samples t-test, and so it's because it's a little bit bigger, even though the mean difference is the same, you actually have a slightly less significant result here compared to over here. So in this case, the paired samples t-test is significant, whereas the independent samples t-test is not. Even though the data is actually exactly the same, you know it's exactly the same because the mean differences are the same. You don't need to know all of that stuff. This is just examples. Here's something you definitely do need to know. The independent samples t-test is reported like this. In this case, we're working with data from hamsters' teeth, and we're comparing the size of growth for orange juice versus VCs. So we looked at this in the previous video. The way you would report this is like this. An independent samples t-test indicated that hamsters' teeth did not grow significantly more. T, DF, t-value here, p-value here, figure 1, with orange juice, mean standard deviation, then with, so it should be VC there, mean standard deviation. So what's going on in this reporting? When you report your t-test, you're always going to give the statistics, and we know where to get those. So t, df, so here's your t-value, 1.915, copied it from there. Your df value is 58, copied it from over here. P-value is 0.06, copied it from here. You're going to want to tell me whether it's an independent or a paired samples t-test. So the stuff in blue is kind of the fill in the blanks part. Hamster's teeth, in this case, was your dependent variable, or hamster's teeth growth was your dependent variable, so you fill that in yourself. You're always going to want to report some sort of graph, which is called a figure, and you just tell which number of graph you're working with. So in this case, your results section is probably just going to have the one graph, so we're just going to say it's for figure 1, and I'll show you how to copy that information and paste it into your Word document in a moment. And then you want to report your two groups, and with the means and standard deviations, I'll show you how to get that information here in a second. Just to give you a simpler slide to show you this information, when you fill in your t-test, the statistics for your t-test, are going to look like this: T, DF, fill in the blank, fill in the blank, fill in the blank for figure, and P. Let's go ahead and run that using Jamovi and the sample data set. Again, to get to the sample data set, you're going to go to 3 lines, open, data library, tooth growth, and for whatever reason it's blank, scroll down, scroll back up. There's the data. We're going to run a t-test. It's an independent samples t-test comparing the length of teeth between the two supplements the hamsters ate. We're going to ask for the descriptives and the plot of the descriptives. And so here's the information. I can make this a little bit bigger. No, make the window bigger. All right, here's your statistic, your DF, and your P. Here's the means for the orange juice group, the mean for the VC group, standard deviation for the orange juice group, standard deviation for the VC group, and here's your plot. If you want to copy this plot, you can always right-click on stuff and make sure you select the correct thing. In this case, we're going to copy the image. Open up Microsoft Word. There's Microsoft Word. You can paste it in. And we can paste this in and use this for our results section. So again, let's see how I'd report this. Write it out. I would write out here based off of this data here. Whoops, I actually popped up the wrong thing. Here it is, tooth growth data. And the analysis isn't run yet. I'll just run that analysis again. There we go. So the way I would report this is I would say an independent samples t-test found a significant difference, parenthesis, t, parenthesis, now we're going to put our df, 58, close the first parenthesis, equals, and now we're going to put our t-value, 1.915, comma, p equals p-value here, 0.060, comma, and we're going to say this is figure 1. Close the whole statistic, and we'll finish out the writing. An independent samples t-test found a significant difference, whoops, between the between teeth growth in the orange juice group, open parenthesis, M, capital M, equals 20.663 for the orange juice group, comma, SD equals 6.606, and the VC group. And again, we're going to put that same information, so I'm going to go ahead and copy this stuff, paste it, period at the end after the parenthesis, and we're going to just change the numbers here. The mean for the VC group, according to this, is 16.963. Standard deviation here is 6.06. And then at the end of the paper, you will have a figures section. So I'm going to hit Control Enter to start a new page. Call this the figures. Make sure it's bolded. Then hit Enter. And this can be figure 1. There's figure 1. It's telling us that the length of teeth was longer for the orange juice group than for the VC group. And there's very, very simple result sections there. Okay, so why would we do a paired samples t-test? Well, if you run a paired samples t-test, it's going to ask for 2 continuous data points. Now, we're not working with data that works with that, but let's say that we do want to do this. In this case, I would go to the bugs data set, bring it up here, and we want to compare data for the bugs based on comparing LDLF and LDHF. I don't know what that is exactly. I think it's low disgustingness, low fear, low disgustingness, high fear. So this is data about bugs. And people rated, there was different people who were identifying some number, I think it's how much they liked a bug that they considered to be low disgusting, low fear, so not very scary, how much they liked a bug that they considered low disgusting, high fear, so very scary. And you can see that these are 2 paired samples of data, 2 paired continuous data points, because they come from the same person. The same person made ratings for different types of bugs. So if you want to run a t-test in this case, you're not going to be able to run an independent samples t-test between these 2 because there's no continuous or categorical independent variable that compares between those 2 things. Instead, you want to run a paired samples t-test and say, I want to compare between the low disgusting, low fear and the high disgusting, high fear. So when you click the arrows, it pops them in. You can run as many as you like. You can also get rid of them by using that arrow and clicking on the things. There's your paired samples t-test, and it works pretty much exactly the same as the other t-test that we were running. You get your t statistic, your df, your p, your mean, standard deviations, and your graphs. So reporting it actually works exactly the same. Okay, back to the PowerPoint. A correlation is a comparison between 2 groups. We looked at correlations in the past. We're going to work with correlations when we're analyzing data from continuous variables. When you report correlations, they work almost exactly the same as t-tests. Instead of a t, you have an r. You don't have a df value, so it's just your r, your p, and your figure number. So let's run a correlation. In this case, I'm going to go back to my tooth growth data. And I'm going to run a correlation between the dosage of supplement that the hamsters got compared to how much their teeth grew. So to run that correlation, I'm going to go to correlation. And we're going to say that the dosage that they got compared to the length that they got. If we ask for a correlation matrix, this is actually what's going to make it easy to understand the data that we're working with. We can see on, oh gosh, why is this coming up weird? And is coming up super weird. Well, as per usual, Jamovi. Oh, I see what's going on. I see. So in this part, the x-axis is the length. So we can switch these around to make a little bit more sense. Here's the dose. The higher the dosage people got, or the higher the dosage the hamsters got, the higher the length of growth. So here's the length of growth. So it's what this correlation plot is showing you, that the more supplement hamsters got, the more their teeth grew. We can actually compare that over here in the correlation matrix results data. The Pearson's R says a higher number means a more positive correlation. So in this case, 0.8, pretty high number. It's pretty positive correlation. A 0 means no correlation or flat. A negative number is a negative correlation or downwards facing. And your p-value again is going to tell you whether that is significant. Now, significance for a correlation isn't necessarily about positivity or negativity, just the strength of the correlation. So if it's very upwards or very downwards, a non-significant correlation is actually a flat line. To report your correlation, you're going to report it very similarly to the t-test. So in this case, let's report this correlation. I would write out a correlation, a significant correlation was found between dosage of supplement and length of tooth growth. In this case, we don't have means and standard deviations because we don't really have two different groups, so we're just going to put in the statistics for the result. Our R equals 0.803, comma, P equals, in this case it was less than 0.001, so we can say less than 0.01, comma, figure 1, close parenthesis, and you can actually say that this was a significant positive correlation. Again, we're going to copy this graph, copy the image, go to the new page, and we're going to call that figure 1, bold, and put the picture there. And so there's your picture. It's kind of janky because it wants to do 4 graphs for this just one thing, but don't worry about that. It's perfectly fine. You can present this and I'd be happy with it. So there you go. How to run an t-test, independent and paired samples t-test, how to run your correlation. This is pretty much going to be your results section in its entirety already, so there's not much else to go through there. And in the last part of this video, we'll work on how to write your results section, which won't be much more complicated.